Well, hello. Today I've got something very exciting. I have a special guest, and my special guest is David Rangsk Clamage. You might know him from his YouTube channel, Rangsk, and where he does streaming of solving Sudokus and some other podcasts and various things. And so, hello, David. Glad to have you here.
Hello. Thanks for having me.
So we're gonna solve a couple puzzles together. David's brought this puzzle, "The Usual Suspects" by zetamath. That we've done some puzzles by zetamath before, and I'm sure Rangsk has done several by him in the past. And he sent this to David, and so we're gonna try and solve it together. And then I've got another one that we're gonna solve together in a little bit here. Depending on how long it takes us, it might be one video or two videos. I guess we'll see how it goes. I know, David, you're used to doing really long streams. You started out doing 8, 9 hour streams, didn't you?
I did, and that was absolutely crazy, but I have several
It was
streams on my
crazy.
channel. Yeah.
And now you do more
Uh,
like 4 hours, which I still think is kind of crazy. But
yeah, I don't, after having done a bunch of 4-hour streams, it's still, I don't understand how I did that twice as long as that. I must have just been completely loopy by the end of those.
right, right.
Um,
And for the record, you do take bathroom breaks during your streams, don't you?
oh, yes, I do. The 4-hour ones, only sometimes, but the 8-hour ones, 100%. Yeah, a couple bathroom
I
breaks.
mentioned something to one of my kids about the fact that you do these long streams, and they were like, "How did they do that without going to the bathroom?" I was like, "No, no, he takes breaks." So
Yeah, just between puzzles. I'll be back in a minute.
yes, yes. So yeah, people should definitely check out your streams. And in fact, I think I'm gonna be guest solving on your stream coming up here. So on Saturday the 20th, right?
Yep.
So check out his stream Saturday. It's what's the times? You better give it because it's depending on the time zones, and I'm gonna mess it up. So
Yeah, so in my time zone, which is the Pacific Standard Time, West Coast of the United States, it is 10 a.m. to 2 p.m. So if you'd like to translate that to whatever your local time is, I'm sure there's plenty of
I'll,
online tools for that.
I'll throw some right over here. I'm pointing. I'll throw some times up there for various places around the world. We'll do the conversion. So check
All
out
right, and
that stream.
I'm gonna guess which way you're pointing. Is that right?
Nope, wrong way.
Okay, up this way.
Yep, over there.
Okay,
And I always start to
perfect.
point and then realize because it's the opposite on my screen. Anyways. So, all right. Well, anyways, so should we solve this puzzle or attempt to
Let's
solve
do
this
it.
puzzle? That's always the idea. So,
All right. Do you want to go over the rules, or shall I?
why don't you brought this puzzle? Why don't you give us the rules?
All right. So this is called The Usual Suspects. It's by Zetamath, and this is a sequel to Two Truths and a Lie, which you may have solved. Or
I
at least
solved on
seen.
my channel. Yes, actually.
Yeah, so you've seen it on Scott's channel. You've seen me do it maybe on my stream. You've maybe seen Simon do it for Patreon on Cracking the Cryptic. So it's been all over the place. So this has a similar style of rule set here. But it's more of a spiritual successor. I'm sure it solves very differently. So we have normal Sudoku rules, which you don't usually explain what those are, right? I
No.
can.
No.
And then in addition to that, we have standard killer rules. So these cages around the grid are killer cages. So digits can't repeat in a cage, which I'm looking to see.
I don't think there
I
are
don't
any.
think, yeah, I don't think there's any where
Not
that
that I'm
matters.
seeing.
But the important bit is the digits in the cage, they sum to the value in the top left. So I would need to make these three digits add to 8. So for example, I could do 1, 2, that adds to 3. So then I would need another 5, and that would add to 8.
Yep.
So then we also have little killer clues. So that's these clues outside the grid with an arrow pointing in. And so the arrow points at a diagonal of cells. You take the cells along that diagonal, you sum them up, and you get that value. So in this case, 14. And there's no non-repeat rule for little killers. So I could put, say, a 1 here, a 1 here, and then a 1 here, and just
And an 11.
11. I can't even type 11.
No, you can't.
But,
But yeah.
but that, so obviously that's not the answer. But
Right.
That's how you would do that. But we have a very special rule in addition to that, which is for each total, exactly one of the cages or little killers with that total is wrong. So let's be careful about what that rule means. So, for example, there's two 30s.
There's 3 of them, actually. There's one in the top
There's-
right as well.
Oh, yes, so there's
Yep.
three 30s. Now, this is just for...
I think
Oh,
it's for
okay, and then
all
I
of
think
them,
there are-
right? And so, like,
yeah, are there
there's
30
an 18
cages?
little killer, but there's two 18 killer cages as well.
Right,
And
let me
so,
find the other 18.
yeah,
There
so
we go.
one of
Okay,
those 3 is wrong.
right. I
And
think
so
that's how
then
works.
and exactly one is wrong, which means
Yeah.
2 of them are right. We can't have more than one that are wrong. Yeah. Okay.
So this 18 we've got, and so that's mixed. So it could be the little killer that's wrong. It could be one of the cages that's wrong, and we know that it's wrong. So we can't make all three add up to 18. We're not allowed to.
Yes.
And then we've got this 30 here, and
Those
we've got
30s,
two 30s along this diagonal, and I don't see a 30 cage anywhere.
No.
But
I
for
think that's
example,
the
we've got a
only
bunch
one
of tens.
I think that 30 is the only one that is just little killers. Yeah.
Okay, so those are the rules, and I guess we can get started.
Yeah,
right?
so link in the description, as usual, and we're going to give it a shot now. Here we go.
Okay, so I'm wondering if we should color things that all have the same rules. I don't know if that's helpful or not at
I
this
mean,
point, but
that might be a good way to start. We might want to, uncolor them once we kind of get going.
Right.
But that might be a good thing to do at first, just to kind of...
So I'm going to be using a lot of different colors here.
So you
do
color
see the other
those, and I'm
8s?
going to keep looking at
Okay.
things.
So I've got the 18s that we pointed out.
Yep. And then there's the 23s. There's the one in row 4, and there's your 10s. Yep. Row 3 or row 4, box 3, and then the little killer as well. Box 3.
Box 3.
It
There's
overlaps
a
the
20.
10 thing.
Oh,
yeah,
it overlaps with the 10. Okay, we'll use orange.
Well, at least we can do the multicolor here.
So what I'm wondering is if there's any. Are there any clues that only appear once? And if so, does that mean it's wrong?
I don't see any that only appear once. There's 3 30s. The other 30 is the other little killer from the top right. Going down,
I see. From here. Yeah. Oh,
which is going to
super
cross.
overlapping.
Oh, that's awesome. It crosses the other 30s. This is just
I
going to
wonder
make
if
it really...
this is overload information here.
Yeah, maybe, but... So one thing that I'm noticing while you're highlighting these things is I don't see any like super obvious, like there's the 23, the 17, and the 5 in box 3, right? Which adds to 45, as we know every box does, because the numbers 1 through 9 sum to 45. So it's not like, oh, these numbers don't sum to 45. And the same thing in box 1, we've got the 2 11s and the 23. But one thing that does tell us is if one of those 3 is wrong, 2 of them have to be wrong. Right? Because if one of those 11s is not 11,
box,
and in fact, the 2 11s can't be wrong. So if one of those 11s is wrong, the 23 also has to be wrong.
Okay, yeah. I was actually trying to think. Okay, yeah, you're right. There is that extra
So there's
case.
kind of a mutual relationship there. Whereas if one of those 2 11s is wrong, the 23 is wrong. And if both those 11s are right, that 23 also has to be correct.
Yeah, so these are either all 3 correct or the 23 and
one
of the 11s is wrong.
Yes.
Okay.
Now, is there anywhere else that a
cases.
23 and an 11 are related to each other?
Well, where's the other 11, I guess?
They're down at the bottom.
Let me highlight them here. Are there 3 of each clue? Maybe that's
I think there's only...
Here.
Oh, there's 3 11s. Is there 3 of all of them? Maybe. I mean, that would make sense if you're following up from his 2 truths and a lie puzzle.
I try to be kind to colorblind people when I color, but we're going to have so many colors here.
And I am one of those colorblind people, so I'm glad I've got you here.
Okay.
Now, I am noticing, so that 11 at the bottom has the same type of deal, because we've got 17, 17, 11. And it's the same as the thing up above, because, again, if the 11 is wrong in the row 9, one of the 2 17s will have to be wrong. And if one of the 2 17s is wrong, the 11 will have to be wrong. It's, again, tied in to each other, right?
If this 11 is wrong, these 2 11s are right, which means the 23 is right.
Correct.
If this 11 is right, that means one of these 11s is wrong,
which
and
means
so
one of those
23 is wrong.
So the 11 and the 23 are actually connected,
they're linked,
but opposite, right?
Yeah.
They're opposite
parodies.
It's almost a parody thing.
Yeah.
Now, it's tied in with the 17s, and I noticed box 3 has a 17 and a 23. And remember that we were started with the 23 in box 1. So again, if that 17 is wrong, that 23 is wrong. So those are the same parody, essentially, right? That 17 and 23 up there.
Yeah.
And so if that 17 is correct,
instead.
if that 17 is correct, that 23 is correct. Which
I
then
don't think
means,
this coloring is helpful.
Yeah.
So let's start over that.
Yeah.
Let's look at. Okay, so let's start with this 11 because I understood this 11.
Yes.
I'm going to use 2 colors, blue and orange.
Okay, so whether that's correct or not, the 23 in box 1 has to be the opposite.
Is the opposite for sure. And then these also.
Yes, that's correct. Those have to be We don't know because one of those two could be
yeah.
wrong, but we know those two at least. Now,
Yeah. You were saying something about the 17s now.
right, because
The 17 has the same parity as the
if
11.
the
No,
11 is
opposite.
wrong, one of the 17s is wrong, so that 17 in box 3 will be right. If that 11 is right, the 17s are both right. So it's an opposite. So that 17 has the same parity as the 23 in box 1.
Yeah, that's what I was about to say, but I agree completely.
Now there's a 23 in there. So the only way that the two 23s... Now that 17 has the same parity as that 23 also. In box 3. Because it has to add up to 40 because of the 5. And so if the 17 is wrong, the 23 has to be wrong. Right?
And now we know that these 23s
so those
have
two
the same
23s
parity.
have the same parity, so they both have to be correct.
They both have to be correct.
There we go. So we know the other 23 is wrong, and we know that the 11 cage in the bottom is wrong. There we go. Beautiful. And that means the
which 11 cage were you talking about?
The 11 in row 9, because it's the same parity.
Oh, right. Yeah, this one's
blue.
wrong. Yeah.
I think that's blue. And
yes,
so the
blue.
two 11s in box 1 must be correct as well.
Yeah, so these are
correct.
Well, unfortunately, orange means correct and blue means incorrect. I can switch it.
That's fine. It doesn't matter. That works for
yeah.
me. So we know that 23. I think 23 and 3 is only one option, right? That diagonal, the little killer in box 1. 23
yes,
and
right.
3 is 986. Yeah, I think it has to be 986.
I remember that 987 is 24, and there's only one way to subtract 1 from that. So.
And since we don't, okay, so we can't color it yet, but we know that one of the 17s in row 9 is wrong.
Yeah, so one of these two, which means if there's another 17, then it's right.
Well, it was the one in box 3 that we already labeled as correct.
I see.
Yeah, that's what we used to get
Fair
there.
enough.
Yep. Now,
do we want like a color to signify one of these two is wrong, like purple or something?
Sure. We can remember that. What all the colors mean. Now, but I'm drawn to the 12 cages now. Because we just stuck that 6, 8, 9 in there, and can you do? I mean, 12 and 4 has to have. Yeah, you can't have an 8 or a 9, so one of those two has to be wrong. Because 12 and 4, you can't put an 8 or a 9 in a cage. Because if you have 8, you're gonna have to make 3 you have to make 4 in 3 cells, which you can't do. So
so either
so one of those two has a 6 and is correct, and then there's the one in row 1 also.
Oh, I see. There's the
so one of those two has a 6 and is correct, has 1, 2, 3 with it, and the other one is the incorrect, which means that 12 cage in box 5 has to be correct.
So this one has to be correct.
Yes.
So it's orange. Because one of these is wrong. And one of these is going to be 6, 1, 2, 3, and the other one's whatever.
Right. Yep. Very good. And you removed the 6 from row 2, column 2. Good job. Yep. I didn't even see you do that, but yeah, that's good.
Yeah. I did it while you explained.
Yes. And so we know the 12 cage in the middle has to have a 1 and a 2 in it as well. 12 and 4 has to have a 1 and a 2. Because if you didn't have a 1, the minimum would be 15. If you didn't have a 2, it'd be 1, 3, 4, 5, which is 13. So.
Yeah. Definitely. These 8s are very suspicious, but I don't know if we can do anything with them yet.
Well, we do. Well, an 8 and 3 has to have a 1, right? And 2 of those have to be true 8 cages, so there has to be, like the ones in box. I
can't fit enough ones. Yeah.
So you could pencil mark 1s into there, I guess. Somewhere in those.
Yeah, there's one somewhere in these boxes.
Look at what that does in box 4, 5, 6. Because of our 12. We know
right, the 1s are limited
the
here.
1 and but the 23 cage is false, so you could put a 1 in there.
Yeah, 23 cage is false.
Well, you could probably put a 1 in there anyways, couldn't you? Yeah. But we do know there's a 1 up at the top there.
Yeah. That's a good point, because these all line up.
Yeah.
Does that affect this 18 cage at all? I don't see how it would.
No, I don't think so, because the 18 is going to be more... Well, 18 and 3 is just going to have tons of options, I think.
Yeah, I think so,
You can put small numbers, if you put a 1 in, you'd have to have a 9 and an 8 with it, right? But it is possible. Well, we can't put a 1 in it now anyways. Plus, we don't even know if the 18 is real, so... I don't even know... I was trying to think, with the 8s, can you say that one has to be 1, 2, 5 and one has to be 1, 3, 4? But I'm not sure you can even say that.
Well, so let's look at all the options. I think that is true, because
I think if you only have column 7 and column 9 being the true ones, you would have to have 2 versions. But I think otherwise you could have, because for example, you could do the ones in the top of column 7, the bottom of column 8, and then you could do either way. They could be the same or different.
these could both be 1, 2, 5 like this.
Yeah.
And that would work just fine in
Yeah,
the box
so-
and in the columns.
Yeah. Well,
so-
they'd both have to be 1, 3, 4 because of the 5 up above. But the point is they could be the same, yes.
Right.
So that I don't know that we can do... Is there anything else we can do with
So
the 8?
if this one's true, it has to be 1, 3, 4.
Yes,
That's an interesting
we do
point.
know that.
So does that... If that broke anything, that would certainly help.
Right.
We don't really know anything about
Is there
this
any
one
way
from
we
the
could figure out
17.
which of those two 12s is the wrong one?
We are looking at 12s. Oh, these two.
Yeah. Wait a minute. What about... okay, so that's 12 across in row 1. I think that one might break. If that's 12, we've got 33 for the rest of the row. Right? But that 11 cage and that 23 cage, because we know those are true, those are only 34 together. So the 11 that kind of comes over in box 1 there, and the 23 that zips down in box... So the parts that are in row 1 would have to be 33, because 45 minus 12.
Yeah, so...
So you'd
okay,
have to
so
only have
let me,
1 for those other 3 cells. Does that make sense?
So let me think about it the way that my brain wants to think about it, because I
definitely.
can confirm.
And that
So
might help
if-
because there's people that don't always understand the way I'm thinking about things. So
this can add to a maximum of 10, these two cells.
correct, yes. That's a good
And
way to
then
think of it.
we could have 3 in these two,
Correct.
just naively. So this could add to a maximum of 20.
Yes.
So these add to a maximum of 30.
So if
we know
that's
the whole row
12,
is 45. So this would have to add to a minimum of 15.
right. So that one
there's
can't
no
be
way
the
it's
so
12.
that has to be the fake one. Or
This
the,
is the fake one.
wrong one or whatever you want to call it, yeah.
Yeah, so we'll mark that blue.
And then the
I hope
other
it's clear
12 has
that
to be
The
correct.
6.
It
And
has
then
to
we
be
know where
1,
the
2,
1
3.
goes now.
Exactly. 2, 3. Oh, and now look at the 2s.
Yeah, the 2s line up.
That's
So the
a
2 is forced
2
in the
up
18
there,
cage.
But that could be in the 18 cage. Shoot, I was hoping that was
It
going to
means-
break the 18 cage.
It means none of these 8s can use a 2.
Well, at least not in box 6.
Yeah, not in this box.
But they could still have a 2. And really, the
So,
one...
okay, but what that means is we only get 1, 2 for all 3 cages. So we do have to use 2 different sums now.
Right. So we do have to use 2 sums. That's very true.
Which means there is a 2 in there
That's
somewhere,
true. There is a 2 in there. Good point.
which isn't that helpful, but
Well, it might be at some point, but
yeah.
those 8s remind me of a rocket ship. About the
Yeah,
so.
it's neat. Yeah. Or I don't know if you watched The Witness, but there was a puzzle in The Witness that had like sliding panels.
Oh
and
no,
stuff
but
like that.
that's cool. Yeah.
Yeah.
So the ones that we know are wrong, it's almost like there's just no cage there. Essentially.
there's kind of a
well,
negative
I guess we
constraint,
can't
but-
have. Yeah, we have to avoid summing to that cage. I guess.
But the fact that we've proven it's wrong means we're probably not going to end up summing to that anyway. So yeah,
Yeah.
we can just ignore it.
So I can't imagine we're gonna be able to do anything with the 30s yet. I wonder if the 18s, if there's anything we can do with the 18s or the 14s. The 18s and the 14s, because those 10s don't seem very helpful either. Like 10
Where
and
is the other
2 has
14?
tons of options. The other 14 is a little killer on the right.
Oh, I see this one here. Yeah.
I mean, that one is a little bit restricted because of the 8s, but we...
So these two at most add to 9, right? Because we could hide a 5 and a 4, but we know that. Well, actually, we don't know because we don't know if the. Okay, so 2 of these 8s are going to be correct,
Yes.
and we know that we're using 2 different sums.
Right. So,
So
at
the highest
most
digit
would
is
be
5
9.
and 4.
But
Yeah.
but that's only true if... Right, 2 of the 3 would be 9. You're right. Yes.
Yeah.
But
And so then.
the
these-
issue is going to be
whatever's
more
left over-
limiting the... I mean, it's a small one, so we're not going to be probably using the maximums anyways, right?
Yeah.
Since 14 is a lower number. If it was a 30 or something, then that might...
That's true. I was just thinking these the other 2 add to a minimum. I don't know which 2 it is, but with this one add to a minimum of 5. But that doesn't really do anything. So that's probably a wrong path.
Yeah. What about... Is there anything we can do with that 12 in the middle? Because we know it has to have a 3-6 or a 4-5, right?
So if it had a 3,
That would force a 3 in the 18
That
cage,
would
which
force
would
a
break
3
the
in
18
18.
cage. So that would be
Right.
really good.
so
Is
where are
there
the
a way
other
we
18s?
can rule out 4-5 in that 12 in the middle?
Well, so we got this 18, and we got this 18.
Yeah.
If these are if one of these has to be wrong, then we know this is right, and then we know this can't have a 3 in it.
Can we figure out the 211 cages, the options for them in box 1? Now that we've got 6, 8, and 9, so one of them has to have a 7, which is going to have 1 and 3 with it, right? And yeah, 7, 1, because the only way to do 7 and 4 is 7, 1, 3, and the one that can't be the one in the top left because of the 1, 2, 3 down below in the 12 cage.
Okay, so you're saying it has to be 7.
There has one of the 211 cages has to have a 7, which will have to have a 1 and a 3,
which is
1.
1.
So it's going to have to be.
So if I tried to fit 1, 3, 7 in here, this removes the 1 and the 3.
There, exactly.
Yeah.
So that one has to be
1, 3,
1, 3, 7.
Oops, I typed that very badly. There we go. 1, 3, 7.
And so that one is whatever's left. 2, 4, and 6?
4, and
or 5, sorry.
6,
2, 4, and 5.
Yeah.
Which we can obviously remove.
We can place the 2, actually.
Yeah, and the 4 and the 5 because of the 5 in box 3.
Oh. Givens are invisible to me.
Oh, I know. Yeah, it's especially by the, by this far along in a puzzle, it's Now we can pencil mark 7, 8, and 9 in column 1. Now is that going to break the 14 cage? No.
Well, these could be 1, 2, 4.
Yeah.
With a 7.
Or 1, 2, 3, right?
Or 1, 2, 3 with an 8. Yeah.
It's an 8. It can't be a 9, but that 14 could be the wrong one, and then it could have a 9. So.
Exactly. So
now, interestingly, if the 17 in box 9 is correct, then you would be able to place the 7 on the left side there.
Yeah, so if this wasn't... Well, we know one of these is wrong.
Right. So if the one on the right is correct, you could place a 7 over there, because you'd have to have 8 and 9, but we don't know that. So.
Right.
What about the 18 Little Killer? Is that affected by the 7, 8, and 9?
I was about to look at that. I mean, if it's a 9, these add to 9. That's not a problem at all.
Oh, yeah. Yeah, that's true. And, 6, 5, 7 works. Yeah. So you can do a lot of things. So that's not really...
But we were kind of hoping to prove one of these 18s wrong, so it would be nice to do so.
Well, or put a 3 into the 12 cage, which would prove the other 18 wrong in box 6.
Exactly.
Or in box 6, and then we'd know both of those 18s were right.
So well, proving both of these 18s right doesn't necessarily stick a 3 in the 12.
No, but putting a 3 in the 12 proves those two right. It's a one way but not the other thing. Yeah.
Exactly. Okay, well, if this 18 were right, it has a 2 in it, so it would have to be 297, wouldn't it?
Right. But I don't see any reason why you can't do it, because that 23 in row 4 does nothing for us right now. It's worthless.
Yeah, it's not
since we know it's wrong.
Yeah.
So what happens if we put 1, 2, 4, 5 in that 12 cage in box 5? Is there any reason that doesn't work?
Just to visualize it.
Because if we're hoping to put 3 and 6 in there.
Something I'm wondering about. Okay, so this could be down the wrong path as well. But I wanted to think about these 8s again. We know
one has a 2 in it.
We know one of them has a 3 in it.
And one has to have a 3 and a 4, correct?
Yeah. So is it possible for the 3 to be down here? I think it is.
Yeah, sure, because it could be 3, 4 down there with a 1 up above, right? And then you have 1 and 2 with a 5 up above.
Yeah, that all works. Because I was thinking if we could prove that 3 had to be up here, then now we've excluded 3
right.
Page. But I don't think that works. Unfortunate. If this is in, it has to be 1, 3, 4. Which the 3 or the 4, either the 3 would line up with these 3s, or the 4 would line up with the 12.
Actually, you know what? We said that there had to be a 2 in those 8 cages in box 9.
Mm-hmm.
Is that true? We know we can only put at most 1, 2 in there. But there doesn't have to be a 2 in there, right? We could still do 1, 3, 4 in 2 of the 8 cages if it was the middle one and one of the other 2, I think.
I think you're right. You're right. That's a false deduction.
We know we can't do 1, 2, 5 in 2 of them.
Yes,
but you could still do 1, 3, 4 twice, I think.
So I could do like 1, 3, 4 here and 1, 3, 4 here.
Exactly.
That all works, and so now I don't have to use a 2. Okay. If one of them had a 2, it's down here. But
Yes.
that's not.
Yes. Correct.
These 14s are in a kind of a suspicious
They
layout.
are. They are.
Like, these two cells see the entirety of this 14 cage. And this cell sees the entirety of this 14 cage.
Yeah.
How many options are there for 14? I think there's a decent number for 4 cells.
Yeah. Well, I mean, if you started with like 1 and 2, then you've got 11 left, and there's a
Yeah.
few different ways to make 11. 3, 8, 4, 7, 5, 6.
Interestingly, we do know a 1 is used up here, so they can't both use a 1.
Right. That's true. And without a 1, 2, 3, 4, 5 is the only option for 14.
Right. So one of them is
So
one.
if they're both
of these were
correct,
right,
one of them would have. Well,
this one would have to be 2, 3, 4.
it would have to be
5,
2, 3, 4, 5.
if they're both correct. Is that a problem? I'm really hoping it is, but I don't see it.
It could be. It could be. Yes, it is. Because what did we say we had to put in the other 14 cage if it was correct?
This has to be 7, 1, 2, 4, or 8.
1, 2, 3. And if we've got
1,
2,
2.
3, 4, 5, what are you putting in row 8, column 4? If that's 2, 3, 4, 5, it would have to be a 1, right? But then, does it work? It does work, doesn't it? Because you could do 2, 3, and 4, 5. It just barely works.
Right.
But now you're using, I think you're using too many of the low numbers that you need in the 8 cages on the right side. Yeah, what are you going to put? Yeah, because you need to have something in row 8 in one of those 8 cages.
This uses 1, 2, 3, 4, 5.
You've got to have a 6, and you can't do a 6 in the 8 cage.
Yeah, the 6. We could hide the 6 here.
Well, but I mean, the minimum you
that's
can
the
place.
Lowest, yeah.
One of those 8 cages
Yeah.
has to be correct. So that would break the 8 cages.
It would, absolutely. It would break.
Yeah.
None of these could be
Right.
lower than
It's
6.
the row 8 that would be the problem there, basically.
These would be from, basically what we're saying is these would be from 6, 7,
Exactly.
8, 9.
And you can't put anything bigger than a 5 in an 8 cage.
Right. So 2 of the 8 cages would be wrong, at least.
Right. So one of those 2 14 cages is wrong.
Which means this 14 cage...
The little killer 14 is correct then.
The little killer 14 is correct. So we can mark that orange. So one of these 2 is wrong.
One of those 2 is wrong. But one of them is correct. And if that one's correct, if the one in box 8 is correct, it has 2, 3, 4, and 5. Right? And we need to have...
Is it enough to... Oops.
And if that one is correct, it's 1, 2, 4, or 1, 2, 3. So it has a 1 and a 2. So there's a 2 in one of those 2 14 cages.
So, well, no. So
Guaranteed.
this doesn't have to be... This doesn't have to be 2, 3, 4, 5 if this 14 is wrong.
Oh, right. It doesn't. It can have a 1.
Yeah.
But
if this one is correct, it's very limited. So I wanted to look at it at least.
It is very limited.
It would have to have a 1 and a 2 in it, and then a 3 or a 4 with a 7 or an 8, right? In order to be correct.
I don't think
and we know this one would be incorrect, but it would...
I don't think that's going to... Because you could still put a 5 down there.
We'd be forced to
or
put
a 3 or a 4.
A 3,
or a 3 or a 4,
or
actually.
4 along with a 5, yeah.
Yeah, 3, 4, or 5. Well, and that's assuming one of those 2... If we don't even know that both of those 8s are correct. Those 8 cages.
Yeah, exactly. This 14's correct. I don't know if that helps.
Yeah. Well, I mean, so we can limit a little bit what's in that 11 cage down there, right? At the bottom? I don't know what the good that does us. No, we can't limit it, because it could be all the way up to 10.
So these add to a minimum of 4.
So it could be all the way up to 10, so yeah.
So it could be all the way to 10.
That could be anything. Can't be 10. We know that. but it could be anything 1 to 9.
Interestingly, if it were an 8 or a 9, it makes this 17 wrong. But
that's true. But it's probably not an 8 or a 9. Because that's really limiting what you can put in the rest of that 14.
Right.
And the problem is we know one of those 3 cells on that 14 diagonal isn't
I
restricted
had
by the
trouble
8
with this.
cage.
Yeah, exactly. So like one of these
So
oranges
2 of
isn't
them
even
are
in an 8
fairly
cage.
low because they could be a
Yeah.
maximum of 5, but
Yeah, so we were saying that at most the 2 that are in 8 cages add to 9. So at least
right.
the other 2 add to 5, but
Yeah, okay. I
it
still
doesn't
feel
help.
like figuring out that 12 cage in box 5 would be helpful, but I don't know how
It
to.
really would, wouldn't it?
Now, it's completely unrelated. Look at row 3. Where can we put a 5?
Okay, well, certainly not in this box and not here. So there's a 5.
And if the 5 is in the 10 cage, the 10 cage is broken.
Correct. So
But
if we can eliminate this 5 or prove
yes,
the 10 cage is right, then that helps.
exactly. Either way, it gives us something.
Yeah.
Doesn't really do anything yet, but I just happened to notice the 5s.
That's a good notice there.
What else can we do? So if that's 1, 2, 4, 5, we know the 2s are up there. Now that limits your other 10 cage, but again, we don't know that 10 cage is the one in row 5. Doesn't we don't really know anything about that. Yeah, that one up there has got to be, could be 2, 3 or 1, 4, couldn't it?
If this 10 were correct,
Yeah,
it
could
would
be 2, 3 or 1, 4.
2, 3, or 1, 4. But it would be from 1, 2, 3, 4, which is pretty limiting.
But again, we don't even know if it's correct. So
yeah. Well, I was hoping that if there was something preventing that or causing trouble with that.
Well, so if that's true, those are both in the 23 cage as well. Does that cause any problems? Because then you have
we know
13.
This would add to 5.
That would be 5. So then you'd have 18 and 3, and you would have lost a 5 and a 2, 3 or a 1, 4. I don't know if that's. Is that a problem? I don't think it is.
18 and 3.
No, because you could have, if you had 2 and 3 in the 10, you could do 9, 8, 1 for the other 18.
Yeah, 1, 8, 9, and then the 17.
No, yeah, you'd be fine.
I mean, I think all the math just kind of works out.
Yeah, you're right. So that can still be 10. Okay.
So what I'm wondering is if this is right, and this is right. That's using 3 of 1, 2, 3, 4, and it places the 5.
You're only using 2 of 1, 2, 3, 4, right? To get to 10?
If both of these 10s are correct.
Oh, but but in row 3, are you only using 2? Yeah, I gotcha.
Oh, right, yeah, that's true.
Because it would be a 1, 2, 3, 4 with a 6, 7, 8, 9.
You're right. I was for some reason thinking this also added to 5, and that was just silly.
Yep. We'll blame it on the pencil mark obscuring the number.
Exactly. There's a 5 there, clearly.
So there's got to be more we can do with those 8s, right?
That's what I'm thinking. Like, these 8s are very suspicious. I don't know if there's more we can do with the 14s, like to prove which one actually has to be the wrong one. Like, this is obviously the most restricted, so if one of them's going to be wrong, it's probably this one. The 8s. The fact that this 8 sees a given 5 is extremely suspicious.
Right.
That it would have to be 1, 3, 4. How could, I mean, this 17 can be right in a lot of ways, right? But these would be fairly low numbers.
Oh, I got it. Okay. I just saw it.
Okay.
I got excited because I just saw it. Okay. Row 6 is the place to look.
Okay.
Okay, over in box 6 are 8 cages. We know 2 of those 3 cells are in 8 cages.
Right.
So the 2 of those 3 are limited to 1, 2, 3, 4, 5.
Let's just pick 2 to...
Yes. Look at box 5, row 6. What are our options for those 3 cells? Because it's 1 and 2 with 3, 6, or 4, 5. So we can only go 1 through 6.
So we know we have the 1 and the 2. And then, so we need to add to 9 otherwise?
Right, so it has to be 3, 6, or 4, 5. So we can only do 1, 2, 3, 4, 5, 6. So now take those 3, the 2 in the 8 cage, and the 1 in column 1. 6 cells that have to be 1, 2, 3, 4, 5, 6. We
So
have to
these
use
are
a
from
6.
7, 8, 9.
We have to use a 6, and it has to be in the 12 cage.
True. So these are from 7, 8, 9. The 6 is forced into the 12
Which means
cage,
that's 1, 2, 3, 6, and it puts our 3 in our 18 that we wanted.
and it puts the 3 here. That makes the
Breaks the
18,
18, which means the
breaks
other
the
18s are correct.
Wow, that's a great spot.
And it also means we have to have a 5 in one of the 8 cages there in row 6. Those 2 cells in, we don't know which cage, but one of the cages that's correct has to have a 5 in there.
The correct cage has a 5 in it. Okay.
Yes.
It's not this one.
And actually, it has to have a 4 also, because look, we have a 1, 2, 3, 6 quadruple. So they are different, because one's a 5, one's different. A 4. Well, is that true? Nope. Because it just because there's a 4 and a 5 doesn't mean they're in the 8 cages, right?
Right. The 4 could be hiding.
No. It does mean that, because their third one has to be a 7, 8, or 9.
Right. The third one is a 7, 8, or 9.
Yes. So they are different. One's a 5 with a 1, 2 down below, and one's a 4. And so now we know it can't be the 2 in column 7 and 9, because one would be a 5 with a 1, 2 below, and one would be a 4 with a 1, 3. You'd have 2 1s in box 9. If you put 4 and 5 in the 8 cages in row 6 there,
yeah.
If it's 7 and 9, you'd have 1s below in both of them.
I see what you're saying. Okay, so if these 2 8 cages were correct,
one would be 4.
One would be 1, 4, 5. One would be one would be 1, 2, 5. One would be 1, 3, 4.
But the 4 and 5 are at the top.
The 4 and 5 would be
so they both have 1s down below.
And they both have 1s down below.
Which means one of those 2 is
this
wrong.
One's correct.
That one has to be correct. Exactly.
This is a 1, 3, 4.
And
we know that
and that has to be the 4.
Forced to be here.
Yes.
Yeah. And the one needs to hide up here.
Yes. It does.
Because otherwise it would remove the 1.
And also, so row 5, column 5 has to be a 2 or a 3, because it's got to be the same as row 6, column 1, because of the quad in row 6, right?
Yeah, so the 6 is down here.
The 6 and the 1 are definitely in there. Yes, so the 2, 3 has to be above it. It has to be the same as the one that's on the other side, because they both...
I'm going to get rid of these corner marks.
Yeah, there's kind of 2 quads going on there, so...
Yeah.
But we now know there's a 5 with a 1 and a 2
same.
below it. Over in one of those 8 cages.
And so we know this one's correct.
We know that one's correct. We also know the other 18s are correct, actually. Because we've...
Yeah. So this 18 is correct.
And the little killer.
The little killer is also correct. We're getting very colorful here.
Yes. But we're also getting digits in the grid, which is exciting.
Yes, that's very exciting. I was going to point out that these 2 are the same digit.
Yes, they are. Matters, but... Yep. So now our 14 little killer is starting to get limited, because we have that 3 in there, and we know... and this is interesting. So we could put a 5 up there, right, at the top. Yeah. But if we do, it has a 1 and a 2 below it. So then the next cell down becomes a 4 minimum.
Yes. So if this was a 5, these add to 8. This one would be the wrong 8 cage.
Right, and we've got a 1 and a 2 below the 5 then in that situation.
3. So this would be 4 minimum.
And you're already at 12.
So that adds to 12.
So you could this would be a 2. You could still do that.
So this would be a 1 or a 2.
Yes, correct. 1 or a 2.
But we don't know that that's what's happening.
But if it's the other way around, that one's 5. And then the minimum you can put in row 6, column 9 would be a 7 if it's not a 5.
That adds to, at minimum,
11.
11.
So that's a 1, 2, or 3.
Yep, that's what we learned. So I'm going to put 5, 7, 8, 9 here.
Yes, good plan. So that 1, 2, and 3, how does that affect the 14 cage in box 8 then?
This can't use... I mean, it can't use all 3 of them. So it can't be 1, 2, 3, 8.
Yeah, but it still has a lot of other options. I mean, even without a 1, you can do 2, 3, 4, 5. And then... Now, it has to have a 1 or a 2, doesn't it? We know that much.
Yeah.
And we have a 1 and a 2 in the 8 cage on the right. also in row 7, 8. So we know there's a 1 or a 2 down there in the 17. Is that a
I don't
problem?
know. I don't have a good way to mark that, but
No, but is that a problem?
for the 17,
Yeah, no, it's not.
it's actually useful for the 17,
Yeah,
isn't
it
it?
is.
Well, okay, so this 17, if it was right, can no longer be 8, 1, 2, 3. Wait, no, that wasn't one of the
No, no,
options.
no. The 14. The other 14. Same thing.
The 14.
We know there's a 1 or a 2 in the 14 cage in box 8. And there's the
If
1 and
it's
2 over
correct.
there. So we can't put 1 and 2 in the long 14 in box 7. And we have to have a 1 and a 2 if that one's true. Oh, but the other... but that's assuming the 14 in box 8 is correct.
Yeah.
Okay. No, it still works though. But not for the same reason. Look at the 14 in row 8, and the 8 cage is on the right. We can't take up the 1 and the 2, because one of those 8 cages has a 1, 2.
Yeah, one of these 8 cages is a 1, 2 down here.
Right, and so you can't put 1, 2,
Closest.
4 or 1, 2, 3 in that long 14 cage, so that one
True.
is the wrong one.
This one's the wrong. Okay, so just to go over that again, this 14 cage needs a 1 and a 2 in it if it's correct. That removes 1 and 2 from these cells. That would force 1 and 2 up here, but ignore our corner marking here. That's wrong because one of these 5 cages is 5, 1, 2.
Yes.
So
that 14 cage is wrong,
this 14 cage is wrong.
which means the one in box 8 is correct.
And unfortunately, we have a correct marking right there, but this 14 is correct.
Yes.
And so
And
we know the
1
14
or
can't.
a 2.
It has to have a 1 or a 2. If it had a 3,
It would have to be down there.
be down there. I'm thinking about how this 1, 2, 3 might affect it.
Right, yeah. I mean, I feel like the 1, 2, and 3 have to be somehow in the 14 cage and that cell down there. Right?
So if this were okay, so obviously if this is a 3, I'm not sure the 14.
No,
is
it doesn't
forced
have to be. You're right.
Could it be 1, 2, 4 something?
Yeah, it could be. Well, it could be 1, 2, 5, 6, or 1, 2, 4, 7. Yeah.
Yeah.
Yeah, you're right.
But if it's not a 3, then the 1 and the 2 are at least within these. But even so, I don't know that the 3 is forced in it. Either way, I don't think that's what we need to look at.
Probably not. That 10 cage in row 5 is starting to get a little limited.
It can't have a 1, 2, or a 3 in it. So if it is 10, it's
it has to be
4, 6.
6, and it has to be
this way.
that order. But that works, doesn't it? Unfortunately, that works.
It just works, yeah.
For now, anyways.
So let's look at these other 10s then. I don't see why any of these 10s would be forced to be wrong at this point.
No, I'm not seeing that either.
We've been ignoring the 30s because
true.
we just don't know that much about them.
It feels like
Let's-
there's way too many options there, but we could look at them.
There's 2 that might be limited. This one has the fewest number of cells, and this one has the most number of cells. I'm not sure
Surely
which
that
one's less
one
likely.
can work. I mean,
The one I'm highlighting now.
there's 7 cells, so they would have to average just over 4.
Mm,
I mean, they'd have to be a little bit low, but
yeah.
I mean, you're going through the 14 cage and a couple of broken cages, and so
Yeah, that certainly seems doable. So this one, what do they have to average? They're 5 cells, so they're averaging 6.
So they'd have to be kind of big. The 1 has to be small. The 2,
We have a 2 or a 3 in it. This 18. Okay, so we know this 18 is correct.
That's true.
So these add to either 9, 10, or 11.
Of course, the ones that have the most options, right?
But this can't be a 1, 2, or 3.
Okay, so that's at least a 4.
So if this were a 4, and we need to add to 9, 10, 11, this would be 5, 6. Can't be a 7.
Right.
If this were a 5,
It would have to be
4,
or
We
6.
couldn't add to 10, so it'd be 4 or 6. If this were a 6...
But then you start to get more options. As that gets bigger, then you get more options down there.
Yeah. So I'm thinking it's hard for this to be low, but...
Yeah.
I don't know if we want to completely good lift this, but it was...
Yeah. It's not quite limited enough yet, is it?
Yeah. This 789 being used... So it's a bit suspicious that this correct 18 cage has 1, 2, 3 not available in this cell and 789 not available in this cell.
Right. So it feels like it's going to have to be a bigger number at the top and a smaller number at the bottom, but...
Or if it somehow got squeezed, then it would be very clear what it was for a low number here and a high number here. But we have a 137 here and an 89. Like,
yeah. Almost have a 13789 quintuple, but there's only 4 cells.
Yeah. Well, we know the 789 can't go here.
Right.
Can this be a 7, 8, or 9? If it were a 7, we'd be 7 plus 8.
And then you'd have
15.
3, which wouldn't work.
Can't put a 3.
You could do 792 though.
792. Yeah, so if this were low, this could even be in the 789 range.
I feel like, that is going to be somewhat limited, actually. The bottom one of that cage, because of the 14, and we have a 1, 2, and 3 on the right. Right? The 14 has to have a couple of lower digits.
Yeah.
We've got the 1, 2, and 3 over there. But it's not quite restricted enough, I don't think.
These are squeezing it almost. Like if the 14 were forced to have a 2 in it, right?
Wait a minute.
I know this is a lot of supposition.
Think about the 14 cage, that one, and the 1, 2, 3 below it. That's 5 cells with a maximum of 17.
And 1, 2, 3, 4, 5 is 15.
Right. So 1, 2, 3, 4, 7 or 1, 2, 3, 5, 6 is, I think, the only way to make 17, right?
17. Yeah, we need to add 2, so we can use a 7. So we could do 1, 2, 3,
4, 7 or 5, 6.
4, 7 or 5, 6.
Now that's if that's assuming there's a 3 at the bottom.
Yeah.
If it's a 1, for example, it's 1, 2, 3, 4, 5. If it's a 2, it's 1, 2, 3, 4, 6, I think it would have to be.
Well, if it's a 1, you can't use a 1 in the 14.
Right, so it's 2, 3, 4, 5. But even if that's a 2 at the bottom, the 5 cells together have to be 1, 2, 3, 4, 6, because it has to equal 16. That'd be the only way to do it.
Yeah.
So they definitely have a 1, 2, and 3 in them. Those
in
5 cells. Those 5 cells together have a 1, 2, and 3 in them for sure.
Yeah.
I don't know what that
3's not here.
tells us, but
I don't either. It's hard to say, but we also know that the 8 and 9 are squeezed.
Yes, into
these
those
4.
Now, if the 17 in box 9 is correct, that would place the 8 and 9 in those other 2, or at least not place them, but
yeah.
It would
so
put
if this was
yeah.
if this was an 8-9, that would force an 8-9 into these 2.
Yeah.
And it would mean this 17's wrong, so we just have a bunch of wrong cages in this box. Like the 11 would be wrong, the 17 would be wrong, the 14 would be wrong. Oh yeah, so this 8-9 squeezes an 8-9 here. It puts a 7 here.
So there's
it does a lot.
Yeah. There's definitely a 1 There's definitely 2 out of 1, 2, 3 in column 9 of box 7. Or row 9 of box 7, sorry. Because 1, 2, and 3 are in row 7 and 8 in box 9. And we know 2 of them are in the 14 in box 8 in rows 7 and 8.
Okay, so yeah, so we know this box has 1, 2, and 3
right.
up in.
And the 14 has to have 2 of those 3.
Here's an easier way to think about this.
Yeah.
Where do 1, 2, and 3 go in row 9?
Right, they have to be in box 7. Yeah, that's
they can't
another way
go
to
in
think
this
of it.
box. They can't go in these 2 because we limited it.
Yep. So they have to be in there.
So these have to be from 1, 2, 3. That makes a 1, 2, 3 triple in the row. So these are, I'm not going to mark it, but these are 4, 5, 6, 7, 8, 9.
So I think if the 17 cage is correct on the left, it can't be an 8 or a 9 in that fourth cell.
Okay, so these are minimum 3 plus 7.
10. So we
10.
couldn't put an 8 or 9 in there. If the
So this
17
could,
on the right is correct, you can't put an 8 or 9 in that cell. So that one
right,
cannot
so
be
it's
8
never
or
an
9.
8 or 9. This is actually fairly limited in its options.
Yeah.
I'm pretty sure.
In fact, so you said
If it were
10 was the
correct.
minimum, but then you'd have a 7 when you'd be repeating a 7. So we actually can't even do that. If you did 7, 1, 2.
Yeah. 7, 1, 2, we'd have to repeat the 7, so we can't do that. So 7, 1, 3 would be 11, we'd put a 6.
Yeah. Fortunately, that works, though.
So 6 is the highest value that can go here, if this is correct.
Right. So it's a 6 or less, but it has to be bigger than a 3.
We know
So
these 5 are from 1 through 7. I'm not sure that's helpful. At least not at this point.
No.
But this 1, 2, 3 is on an 18
quite limited.
now.
Oh, right.
We know this 18 is correct.
Right. So that's a maximum of 12 then. So that has to be a 6 in the middle. Right?
Oh, because the 7, 8, 9.
Yeah, so that's a 6. And a 3.
This is a 6.
And a 3.
And then a 3 and a 7, right?
Yeah. And now we know the 18. That gives us 17 cages.
18.
What?
Wait, that doesn't add to 18. That's
No,
9.
9. Yeah, sorry. 9. Oh, shoot. So that doesn't give us the 70. Okay. But it removes the 3 in row 9. And tells us
it
that...
does.
Oh, but there's...
So these now add to 16 or less.
Which means they have to have a 3 in the 14 cage.
Right,
it has to be
the
1,
3
2,
was still
3,
limited, yeah.
4. It has to be 1, 2, 3, 4. So there's a 3 and a 4 in that 14 cage.
There's a 4 in here now as well?
Yeah, because 15 or 16 means 1, 2, 3, 4, 5 or 1, 2, 3, 4, 6.
Right.
So that's 7.
Doesn't that mean...
You need another
Okay,
you need another 7 in the 14 cage with the 3 and the 4.
So there's either a 6 up here or there's
it's either 1,
5
6 or 2, 5.
Yeah. Okay, so now what we've done actually is we've used up 1, 2, 3. Oh, hold on. We've used up 1 and 3 here.
Yeah.
So this cell...
Wait, yeah. No, we've used 1 or 2.
Right. We've used 1 or 2 with a 3. Okay.
Yeah.
Well, if this 1 or 2, can this still be a 9? Or wait, hold on. What would that limit? Lowering the max of this.
Right. So that's either that one plus the 3 is either 4 or 5. So the
Yeah.
other 2 need
Add
to be 9 or 10.
9 or 10. So
And 5, 4 was our minimum. 5 and 4 was our minimum. Otherwise, it's 7 and 1, which would be 8. Yeah.
we can't do 5, 5. Do I want to fill this cell? Because we know they add to either. What did we say? 9 or 10.
9 or 10. If that's a 5 at the top there, yeah.
So,
but then that has to be at least a 4.
Well, no matter what, these two add to 9 or 10.
Right.
So 5, 4. Wait, so this kit. Okay, so this is, if this was a 5, this would be a 4. Because you can't do 5. Oh, we could do 5, 5 to add to 10.
Oh, dude. So if it's a 5, I think it has to be a 4 or 5. If it's a 7, it has to be a 2. Oh, but it could be bigger than 7. It could be an 8, and then it could be a 1. Yeah. Okay, so it's a 1, 2, 4, or 5.
Yeah, which is a low number. We've already got a lot of lows going on in this box, so no, probably nothing at this point. But what I was going to point out is the effect on this cell.
Hold on, if we put a 2.
Mm-hmm.
Never mind. Okay. That would have to be 3416 in the 14 cage if we put a 2 at the bottom.
The 2 here?
Yeah, if you put the 2 there, then it's 1346.
Okay.
And the 6 would have to be up there. That would have to be 1. No, yeah. The 6 would have to be up there, the 3 would have to be at the bottom. That seems like it works, though.
Yeah.
Ah, the 3. The 3 in box 7. Up to the top, up to box 1.
Oh, that's easy.
And now we can't put a 7 in the 18 cage. I don't know if that really helps, but it's
so
something.
These add to 10 or 11.
Yeah, and the one at the bottom has to be.
It can't be 1 or 3.
4 or 5, right?
Can't it be a 2?
Oh, a 2. 2, 4, 5. Can it be a 1? No, it can't be a 1. If it's 2, it can't be a 2 either.
It would force the 2 to be here.
No, look at the 18. If it's 2, that's 10 or 11, giving you 7 or 8, but you can't put a 7 or 8 above it.
Ah, this can't be... Okay,
because we have an 8-9 pair and a 1-7 pair. So that can't be a 2.
If this were 2-8, we'd have to repeat the 8. That's no good.
So
if this were 2-9, we'd have to use a 7. Can't use a 7. So that's not a 2.
Now, if it's
a 4...
then you'd have 12 or 13. You would need 5 or 6 above
12 with a 6 or a 5.
Yeah, and unfortunately, those are okay.
5, 8... Well,
13
you can't do 5, 8, 5.
If it's 13 or 14...
So 5, 9, 4?
Yeah. Yep.
So these were both middling, which we kind of suspected would happen. I don't know if we suspected that would happen.
Yeah.
Not, but...
Now we can place the 2 in column 3, though. Which is going to give us the 1. Because that one can't be a 2 because of the 2-3 pair in box 4.
Oh, the 2-3 pair in box 4.
Yes.
Correct. So that places this 2.
And it gives us the 1 at the bottom in box 7.
Yes.
And then the 2 over there. And now we've got 5 on that 14 diagonal. And we know the other 2 have to add up to 9.
Hold on.
We know what that is. Yeah, 1, 3, 4, 6.
Yeah.
And we can remove the 6 and the 3 in a couple spots. And yeah. But also the 14 diagonal. We've now got 2 and 3, which is 5. So we need 9. So now we can't have the 9 or the 7.
Yeah, because the 7 would have to be with the 2.
Yep, and that one down below can't be a 5.
That's a 1, 3, 4 triple. The 3's forced here. It already was, though.
Right. That is, but that removes the 1 from the right. That removes the 1.
So this is not the correct
and that
page.
can't be a 1 or a 2. Where your mouse is right now, it can't be a 1 or a 2.
I just removed it. Yeah, yes. So this is
that has to be the 8 at the top then. Because we know the correct 8 cage has the 5 at the top.
Yep. I'm about to do that. So this is 1, this is 2.
Yes.
This is the 5. This is the correct cage.
The other one's
this
the 8.
one is 8.
Which gives us the 9 over on the left side in the 18 cage.
I'm just making sure that adds to 14. It does.
Yeah.
Good. So sorry, what were you saying?
Yes, so that 8 then over to box 4 gives us the 9 and then the 7 next to it.
So these add to... This can't be a 6 now.
Right, that's 4,
this is a 4-5 pair.
Which gives us the 6 above it in the column. And now also that 7, 8, 9. Because we got the 8, 9 in the row now. Oh, and also the 9 up above to the 8 and 9 in box 1.
Nice. Good scanning.
Nice. Now we're moving. We're cooking with gas, 5s. As some people might like to say.
So who says that?
I don't know.
Okay, so this people, is a 3-4, so that's a 1-6. I feel like that was a huge breakthrough.
Okay, so now look at the 17 at the bottom in row 9. We have the 1 and the 3, the other one. We have the 1 and the 3. If it's 7... Okay, so 7 or 8. So we have 11 or 12.
Mm-hmm.
So that would be what, 5 or 6? It'd have to be a 5. 5 works though, because we can't put the 6 in there.
Yeah, so if this were a 5, these would add to 9, and this would be an 8.
Yeah, so that if that one's true, that can't be a 7. But of
Okay,
course,
but so
but if
so
it
this
isn't true, then it is a 7.
one of these 17s uses an 8.
Yes,
Is the
so we
point.
can't put an 8 in the middle there. Yep.
So 8 is now
One of those two,
these
and
two.
oh,
I almost want to fill these. Because we have 1, 2, 3. We need 4,
4,
5,
5, 7, and 8.
7, 8, and that can't be an 8.
Right.
This can't be a 4. This can't be a 7. Or an 8. 4, 5 pair.
Oh yeah. Well, which we should have been able to get because the 7, 8 pair. Yeah. Yeah. Oh yeah. So that's yeah. There you go. It's 7, 8. We still don't know the 17 cages. Which one is correct?
So this one needs to be a -7. Let's see. Yeah, we still don't know which is correct. So either this is 5, 8,
Or the other one is 8, 9.
or this is 8, 9. Let's see. What do we need? We need 4, 5, 6, 8, 9 here. The 8's definitely in these 3.
Yep.
Do we have to be careful about making the 11 wrong?
The 4 is definitely in row 9 of box 9. Because of the 3, 4 pair in row 8. And it can only be in 2
Right.
options. So it's either If that 17 is correct, the 4 has to be obviously in that one, yeah.
So that would add to 6, so we wouldn't be able to
Oh,
place
but the
5
6
here.
the 6 is also in row 9 of box 9. There's a 4 and a 6 down there. So that
the
17 is
can't
broken.
be right. Yeah,
So now we know what the other one is then. It has to be the 8 and the 5.
there you go.
And gives you the 7 above the 8. Column 1.
Ah, yes.
So 5, 8, and 9. Oh, and yeah, so that row 8, column 4 is a naked single now.
This is 7 or 9. Yeah, so that's 9. That's 7.
And now 5 and
Okay.
8. Oh, and you can get the rest of row 8 on the right side there because it has to be 5 and 8. You got the 8 above.
And this should be a triple as well.
4, 6, 9. 4 can't be in the middle.
Okay.
We know there's a 1 in that 23 cage in box 3 on the right side. It has to be in column 9 there because the one's down below.
Oh, we have. Oh, yeah. These ones look up.
Yeah. So I'm not sure what that really does for us, but it's a
How about
thing.
this 30? We have almost all the.
Oh,
digits.
yeah. Okay, so 14, 23. So we got 23 in there, and then we need 7 more, which would be 2, 5, or 3, 4, unfortunately. That one looks like it could actually be correct.
So if it were correct,
it sure is close.
23, these would add to 7. It would have to be 4. Oh, it could be 4, 3, or 5, 2.
Exactly. What about the other 30 next to it? We've got 12 already. You need 18. You can do 10.
So these could be 10.
8. Yeah, that would work with an 8.
In fact, these are 4, 5, 8, right?
Yes, and we know there's an 8 in one of those two.
That's pretty clear for the triples, so I'm not too concerned about
Yeah.
marking that. We have this 2, 3 pair. Is this 10 getting harder? Could it still be? It had to be 4, 6,
yeah, I
right?
think it can still work though.
Like this.
Which makes me think that might be what it is, just because
Yeah, I
it's still
know,
possible.
It would force the 5
5.
and the 8.
Yep, and then the 4 up above. But I think that's all okay.
Maybe we got to build upwards.
Yeah. Can we do anything with I feel like the 17 and the 23 in box 3 just have way too many options still.
So hold on. These can't be 2 or 3. So they can't be 1, 2, 3,
4, 5,
4, 5. So they
8.
could be
So
6,
there's 6, 7, or
9.
9, and the 7 can't be on the right.
Yeah.
So yeah, those are pretty limited.
So if this time we're correct, we know it's 6-4. We said that already.
Oh,
but...
we can put an 8 in the 17 cage up above. Just by normal Sudoku.
Yeah, these two 8s look up.
And then that one across.
Over.
So there's an 8 in there, which leaves 11.
Correct.
So could be 9-2. Yeah, that would work. Can't be 8-3, obviously. 4-7. 4-7 work? I think 4-7 works too. Can't obviously do 5-6. It would have to be 4-7 or it has to be 4-7 or 9-2. Because we know that one's correct and we know there's an 8. And the 4 would have to be, you can't put the 4 up in row 2. And you can't put the 9 in row 2.
So this is the 8.
Can't it be a 7?
No, because if it were...
Yeah, 2-7.
You said 8 with 7.
Or 4-7. 8 would be 4-7. You're right. No, yeah. Yeah, that can't be a 7. And it can't be a 9 or 2. So that's an 8. You're right.
The best way to put... Yeah,
yes.
If this were an 8, this can't be a 4 or a 2.
Well, if it's 8-4-7, the 4 has to be at the corner of it there. Yeah. And so then
the other option is 8-2-9.
And it can't be a 4. Yeah. That would have to be the 8. So that
can't actually.
It's an 8.
We could have seen. Actually, this cell can't be a 2 or 9.
Right.
So. Okay.
Yes. So that's an 8, and then we have 4-7 or 2-9 across there.
This is 8. The 8.
Oh,
8
look at the 5. Look at the 5 down below, all the way down in row 9. And look at our 10 up above in row 3. So the 5 is in there, which means that's a broken 10. The other 10s are correct. And now we know that, yes.
I'm going to get a bunch of digits now.
Yes, a whole bunch. That's kind of what we were hoping for.
Yeah.
And that's going to give you the 4 and 5. Yep, there you go. You're on it. We get a triple in the 18 cage in box 6. 2, 3, and 7. And you can eliminate some of them. We got a 2-7 pair in column 8 now.
So this should be a single.
6-9 up there, right?
Oh, never mind. 6-9.
Yeah, and unfortunately those are both still possible, but
yeah.
So what's left? Oh, we should be able to get column or row 5 there in the middle. There's an empty one. 7. Yep.
This is a triple. We have 1, 2, 3, 4. We need 5, 8, 9. It looks like. So that's an 8.
Okay. So now we know the 10 little killer is correct. Up in box 3.
True. Yeah. So these add to 5.
And if it's
oops. Oops.
And since we know there's a 1 in the 23 cage, if it's 2, 3, you would have 1, 2, and 3 in the 23 cage. You would need 8 and 9 with it, and we can't put the 8 in there.
Okay, so if the 23 had 1, 2, 3 in it,
it would have to have an 8 and a 9.
It would have to have an 8 and a 9, and it can't.
So if that was 2, 3, it would break because we know the 1 is in that cage. So 1, 4. Yep, there you go. Which is a 9, 2.
Get all these digits.
And now you got the 6 and the 9 as well. Yep.
So these aren't 9s. No, this can't be a 6. That's 4 and 6.
Yep. Nope.
Wait, no, I did something wrong.
Go back. Right there. No, yep. So they can't be 9. It can... Oh, what did we do? Oh, no.
Our puzzle's broken.
Oh, no.
Let's go back
Not this far along.
Here. Did I mark this?
That's a 4 or 9.
This couldn't be a 6. It's a 4-9 pair. But we know... oh, wait. We have 1, 4, and 9 used here. So doesn't that... and a 2.
So that's a 3 up there?
Yeah, this would be a 3 or a 7.
But if it's a 3,
Sudoku.
That puts a 2 down below. Doesn't that... Didn't we just say we can't put 1, 2, and 3 in that? Did I do the math wrong?
Well, let me redo it for you. So, well, let's just fill it and see if it's still broken. Because that does all of this.
Yeah.
This would obviously be a 2. This
That's
would
a
be
7 and a 4.
4, 9, 6, and 4. I mean, Sudoku's just going to fill this, and we can see if it adds right.
Oh no!
This is a 1,
2,
2, 3, 4. 1 and a 6. So 12 plus 9 is 21.
Our 17 cage is wrong.
Sure is.
We did that completely wrong. Okay, you're gonna have to back up. We did 17
Back
minus
up to
8
placing
equals
that 8.
11. That's what we did.
Oh, I just didn't double check your math.
Yeah, you're right.
So
I
gotta move
just
all the way
completely
back
did
to
that wrong.
placing that
Oh man, we were going so good too.
So there's an 8 in it. The rest adds to 9.
The 9, not 11. Wow. Okay.
So if
So
this
it can't
were
be
an
1
8,
8. Can it be 2 7? It
so
can.
Can't be 1 8. 2
It can
7.
be 2 7.
So
Yep.
2 7 would go like this.
Yep. 3 6.
Would
The
go
3 would
three
have
with
to
a 6
be.
there.
No, the 3 would actually have to be up at the top. Yep.
3 would be there. Yeah. 3 6
And 4 5
is not possible because there's a 5.
Oh right, yeah, obviously.
So
Those
we're down to
givens are
these.
invisible.
Oh, this can't be a 6 either. So this is a 2.
So that's a 2. So it's 2 7.
So 2 7. Yeah.
Yes. Okay.
So that's a 7 8 pair.
Yes.
So that's not a 7.
Which gives us a 6 9 pair.
Oh, we still have this 5 here.
Right.
We can still
yes.
do this.
And so we still have the 4 6 in the 10 then in the middle in row 5.
So this is definitely not 2 3. This is definitely 1 4.
Yes. Which still works from my
4.
other logic about not putting 1 2 and 3 in the 23.
Exactly. Yeah. Okay. We saved it.
Okay.
This
that
should
was
be
good.
fillable.
Yes, we should be okay.
This isn't. Is this a 3?
Yeah.
I think so.
Yep. And you've got a 4 in the bottom right
So
corner
this is a 2.
of the grid. Yep. And then
We know what this triple is. 1 2 3
3 6 9.
6 and 9. So the 3's
Can't put a 9 in in row 2. Yep. You've got a naked single in column 8 there.
column 8.
It's a 7. And remember that 10 in row 5 now is correct. So it's got to be 4 6.
Correct.
And so you're still getting all that
So
stuff that we got before in there. And that,
These
that
4s
affects,
look in. There's a 4 in one of these two.
Yeah, well, and you can do a bunch more in row 5 now because of that 4.
Oh,
Just
right,
like we did
yeah.
before.
Like
The
we did
stuff that we
before.
undid that we can now
We did a lot of correct stuff. But
We
I had to
did. It was
undo
just
back
that
to the-
one math error
Yeah.
there.
I didn't trust anything we did after that. So
No. So that still gives us a 7 there.
7
You
there.
got 5, 8, 9 across row 4.
Yeah, so we were very close to being.
Oh, and you got a
correct
5, 9 looking up at the one in column 4 there. So that's
there.
an
Yeah, I think
8,
that happened last time too. Oops.
5, 9. The 4 is also looking at the 3, 4 down in row 8.
True.
Now. Oh, the 1 in row 3, looking at the 1, 7. And then that's going to see the 7, 8. There we go.
So this is a triple.
Yep. 4, 5, and 9. And again, the 5,
It's not
9.
a 5 or 9.
Same 5, 9 that we were looking at before.
Oops. I'm just hitting all the wrong
Yep,
buttons
that's all right.
now.
You're just coloring it instead of.
Uh-oh.
We got a 5, 9. Oh, the negative on the 23.
That's got to
It
be
can't
it,
be a
right?
5.
What are these at?
It can't be a 5 because that's 18.
12, 18. So this can't be a 5.
So there is a negative constraint used there.
How did we prove this 23 was wrong? We must have proved the other two 23s
Because the others were correct. Yep.
Yeah. Oh wow. Okay.
Nice. So
For those not in the loop,
yeah,
we saw this and saw it was a deadly pattern.
Yeah.
Normally in Sudoku, because the 5 9s could be like that,
or the other way around.
or the other way around, and
And so if
no
it didn't say
way to distinguish it.
exactly 1 was
Yeah.
wrong,
then there'd be 2 potential solutions.
So we have to make
the
sure that
puzzle.
one's not correct, essentially.
Yes, we got to put a 9 in it.
All right, nice. Now it's just Sudoku to finish it off, right?
Yeah. Well, we got the
Just
30s. Did we figure out
Sudoku,
the
I say,
30s?
as if it's the easy part or something. Oh, the 30s, yeah.
I'm
So
sure these 30s are going to just
27.
Let's do as much.
So that would
I like
have
to
to
do
be
as
a
much
3
Sudoku
if that
as
one's
possible.
correct. What about the other? We got 6, 18, and 6 is 24. A 6 would work there. If that one's correct, that would have to be a 6. That's 14 and 12. We have 26 already, so you would need 4 in the remaining two, which seems like it would be possible. It'd have to be 1 and 3.
Have to be 1 and 3. Curious. Okay, if this were 6, that makes this 30 correct.
Mm-hmm.
Isn't that what we said?
Yep.
That makes this a 1.
Actually, if that's 1 and 3, all three of them are correct.
That's what I was trying to think.
Because that 3 puts a 3 in row 5, column 1, which makes that 30 cage correct.
That's what I was thinking. Yeah.
Yeah. So 1 and 3 would make all of them correct. So that one has to be the incorrect one.
Yeah. So just to go over that, because I don't know if anyone's gonna understand what we just said.
No, I don't know if I understand what we just said actually.
I'm gonna plunk the numbers just. To
yeah.
be clear
Yeah.
here.
Do it.
If this, oops, other way around, right? This can't be a 3. Oh, well, that's even more obvious.
Well, there you go. It's broken because of that. We didn't even have to do our complicated reasons. It's just broken because we didn't update pencil marks. It's broken
because we didn't update.
That one's just broken.
Just
broken. So the other two are correct, which means you can put in the 6 and the 3 to make the other 30s correct, and that's going to give you a bunch of other digits.
Let's double check these sums. So.
Yep.
10.
He doesn't trust
14,
me now just because I made a math error one
30. Time. Correct. No. 18. 20, 30. Yeah, so these both add to 30.
Yep.
This one's unable to add to 30 because these add to 12
for either
6,
complicated
18.
reasons or for just the simple.
Yeah. So wait, these add to
26.
12, 18 plus 8 is 26. These would have to add to 4. They can't.
Yes.
Okay. In fact, because that's a 1 now.
Yes.
So good. We aren't accidentally.
So
making
you
them
can put
correct.
a 2 in row 5, column 5.
Oh yeah, we know that 2 goes there.
So now that's a 1, 3, 6, and you can't put the 1 in the middle. All right. So now, we can do the 9 in the box 3 because you've got a 3, 6 pair in the right because there's that 9 down below. That's a 9, gives you the 6 and the 9 down below, which actually we could get from the 6 as well.
Yeah, we could have done a lot of ways to do that.
Knew how to scan. All right, so I guess we just got to fill in those. Is there any? Have we used all of the clues now?
I think so. I can color them. So this.
Yeah, I think we've done everything. So it's just a matter of filling in the rest of the Sudoku.
Yeah, let's just fill the Sudoku. So 1, 3.
Well, look
6,
at column
7.
4. You got 1, 2, and 3, and the 2 can't be at the top. The 2 has to be. Like just in column 3, you can place the 2.
Column 4.
Or column 4, sorry, yeah.
Yeah.
Place
so
the 2.
This has to be the 2.
And that gives you a 1, 3 above it.
Yeah, I haven't cleaned these up.
And then row 2, you got 3, 6, and 8 that need to fill in there. And you've got a 3 and an 8 down below in column 6. So that gives you the 3 and the 6 to the right. And then just fill in the last 3.
We're done.
Looks good to me. Timer stopped. Yay. Yeah, all right.
Yay. Okay.
Whew. I don't know how long that took, but it felt like a long time.
Yeah, I think that was probably a movie length solve. Right
yeah,
there.
So that was The Usual Suspects by zetamath. I think we will call that probably it for this one, and maybe we'll do another puzzle and make it a separate video. So you can look for that one coming up. But make sure you check out Rangsk's, which is hard to say, stream coming up on. Well, check out all of his streams, but specifically check out the one on the 20th when you might see me there as well. Do you have thoughts on this puzzle? I thought it was really cool.
I thought it was a cool puzzle as well. Definitely, just like the 2 truths and a lie, it had a very strict path where you had to find the next clue that was clearly one of them was wrong, and I think it was just hard to hunt those down, and I think some math errors may have led us astray a bit, but
maybe one in particular.
Yeah.
17 minus 8 is 9. That's our lesson for the day today, not 11. Yeah, I thought it was great. It was definitely you had to figure out you just had to figure out which ones to look at, I guess, to know how they were restricted. And I thought it was cool. It wasn't just we used the 11s with the 23, and then the other 11 with the 17s, and then that 17 with the 23. It wasn't like just 11s with 23 and then 11s with 23 somewhere else. It was kind of a
Yeah,
ABC situation. So
the parody coloring really helped us break
yeah,
in. I thought
that
it
was
was
a good
really
idea. Yes, definitely.
Yeah.
So all right, very cool puzzle. We'll see you again soon with some more puzzles.
All
Thanks.
right.
Bye.
Thanks, everyone.